Hello and welcome back. Last week we looked at adding collision detection to trigger the death of a player and reset the game back to initial state. This week we're adding a missile to let the player start to fight back, although there won't be any collision detection on the missile, so you won't be able to shoot the asteroid just yet. As usual, let's make sure the code from the previous tutorial compiles. You should get the usual spaceship and asteroid, and then when the asteroid collides with the player should die and the world resets to its initial state. If you don't have this code, then you can do git checkout tutorial 9 to get that code. The first thing we'll do is add in the image of the missile to the image folder. You can get the image from the GitHub repository, linked below, or draw your own. It needs to be 50 pixels by 100 pixels. We want to add a new file into the source folder. This file will be called missile.rs. We'll be using the usual specs import, the same as in asteroid.rs. For convenience, we will add in calls to use crate components to save us typing the crate root. Then we'll create a pub struct for our missile mover dispatcher implementation. This will be very similar to the asteroid mover dispatcher in tutorial 8. And underneath that, we will implement system for the new struct, noticing that missile mover had an accidental S on the end, so we remove that. Then we create the type of system data, as we did before. The first component that we will reference is the write storage reference to component's position. Second, we put in a reference to the renderable components. Then we add a read storage reference to the missile component, because we don't actually need to update anything on this component. And finally, we add in a reference to the entities, which we will need because we need to remove the components associated with the entity later on. Then we create the run function. It takes an argument of self, which is mutable, and also a reference to the system data type above, simply called data. Then we unpack the objects in the data object, positions, renderables, missiles, and entities, as a tuple. Then we create our for loop, iterating over the positions, renderables, missiles, and entities. We need to remember which are mutable so that we can include the mute keyword. And we add .join on the end to complete the iterator. First thing we need is the rotation of the missile and to convert it to radians. This is probably very familiar. Then we calculate the movement in the x direction, the missile speed multiplied by the rotation dot sign. And the same for the movement in the y direction using radians.cos. And then we do the movement by adding the move_x value to the position.x. And we subtract the move.y from the position.y. And now we check if the position is greater than the screen width, adding into to do the type conversion for us. And we can also check if the position.x is less than 0.0. Or the position.y is greater than the screen height, again adding into. Or the position.y is less than 0.0. Then we can call entities.delete, passing in the entity, and adding OK on the end to remove the warning in the compiler. And finally, we set the renderable rotation to be the same as the direction of travel to make sure we draw the missile facing in the correct direction. And that's the whole function to move the missile completed. Next we move to the components.rs file to add in the missile component. We can simply copy the last component, the asteroid, and use this as our basis. We rename the component to missile, and we remove the rotation speed because we don't need that. Returning to our main.rs file, we first need to make sure we include the new module by adding pub_mod missile. Then we scroll down to the area where we load our textures and add in the call to pre-cache the missile image using textureManager.load. And then we scroll down and register our component with the ECS system. We can simply copy the asteroid registration and change the name. And we've added a new dispatcher method, so we can add this underneath in the dispatcher builder. The same as before, we add a call to with and pass in the values of missile, missile mover, and give it the same name in snake case, and an empty list at the end. We also need to add an entry to our key manager for the spacebar being pressed. We do that in the same way as we've handled the escape key, but we pass in an empty string instead. We can save time by copying the key down pattern match for the escape and modify that. We edit the filtered key to be space. We can copy the utils keydown call from below and add it to be the value of an actual space inside quotations. We can then copy the key down and change the relevant values to key up instead. We switch back to game.rs, and the first thing we do is add a call to use create components and create utils to save some typing later on. After our must reload world check, we add in a new variable to hold the current player position, and the type is components position. We give it values of 0.0 and 0.0 and a rotation of 0.0. Then we create a new variable called mustFireMissile. This is a boolean, false by default. Next up, we're going to need to scope everything inside the following block to help the borrow checker know when it can release references to things. We scope this by indenting the rest of the function and then adding the matching close bracket at the end. Then, after our boundary checks, we're going to check if our utils is key pressed indicates the spacebar has been pressed. If this is the case, the first thing we do is set the utils key up function, because we don't want to double press the spacebar. Then we must set mustFireMissile to be true, and then we store the values of the current player position, both x and y, and the rotation. This creates copies of these values. Finally, underneath our scope section, we create a new if clause to check if mustFireMissile is set to true. Next, we call a new function, which we will create in a minute. The function is called FireMissile, and it will take arguments of the ECS world object and the player position. We then scroll down to the bottom of our file. The first thing we'll do is create a const called max_missiles. This will set the maximum number of missiles allowed on the screen at once. It is of type usize and a value of 3. Underneath this, we create our function FireMissile, which takes an argument of ECS, type world, and the player position, as position of type components position. Next up, we're going to create an inner scope. Inside this scope, we'll create a variable which will hold a reference to all of the missile components within the world. We can get this via the readStorage method and pass in the type of component missile. Underneath this, we'll create an if statement to check if the current number of missiles in the world is greater than the max missiles, subtracting 1 because the count is not zero-based. And if that is the case, we will simply return. Next, we'll create a new entity by calling ecs.createEntity. Then for the first, we will add the position component passed into the function. Then we add a renderable component. And we'll fill that by copying from the asteroid above and pasting the content. We update the texture name to be missile instead of asteroid. The input width is 50. The output width is 10 and the output height is 20. We add our final component of components missile. We set the speed to be 5.0. Finally, we call build to finalize the new entity. Then we call cargo run to test the new code. And there we have it. The ship now moves around and we can fire missiles. The asteroid can still reset the system when we crash into it, and missiles simply pass through when they collide with the asteroid. This is expected. Join us next time when we will add in collision detection to the asteroid and give the player a chance to avoid being hit by the asteroid. If you enjoyed this video, please don't hesitate to subscribe to the channel and get notified when the next one comes out. And if you have any comments, please leave them down below. For now though, I'll wish you a great day and hope to see you again soon. Bye for now.